Hey, what's up guys, my name is Cherno. Welcome back to my code review series, the series in which you guys send me your wonderful code. Today, we're going to be taking a look at what I think is a really good project for beginners or people learning programming to do, and that is the classic Tetris. So Adam writes, "Hi Cherno, I hope this email finds you well. My name is Adam, a Nigerian studying computer science in India, and I'm a big fan of your YouTube channel and the incredible content you create around programming and game development. Your tutorials and insights have been invaluable to me as I continue to learn and grow as a developer. I recently completed a project where I created a simple Tetris game using the raylib library in C++. Raylib is a great library. I recently used it for the first time to remake my first game. I'll have that video linked up there. So I kind of know how it works now, which is good. I would be honored if you could take some time to review my code and provide feedback. I'm eager to learn how I can improve my coding practices and the overall design of my project. Here's a link. We'll take a look at that. Thank you so much for considering my request. I understand that you have a busy schedule, so any time you can spare would be greatly appreciated. Yes, this was sent in June, and I'm only just getting to it, so I'm sorry. Looking forward to feedback and suggestions you might have." Okay, cool. Well, this is a little bit different from the emails that are like, roast me as hard as you can. So we're going to try and be nice here. We're going to try and give some good feedback. Here we have the GitHub repository. I'll have that linked in the description below in case you guys want to take a look. Very suspicious, all of these exe files that are over here. I'm not sure if I want to take a look at those. We got a make file. We got a main.code workspace. So I'm guessing this is Visual Studio Code. I might just open it in that instead of Visual Studio like normal. Here's the actual game. We got like a nice screenshot. It uses raylib. Clone the repository. Ensure that you have raylib installed on your system. One thing that would have been good, I think, just immediately looking at this is if you don't have to manually download raylib, and then also the fact that this is using a make file. Right, so this is a raylib make file. Yeah, I mean, this does expect it to be installed over here, and it doesn't look like it will install it for you. So one thing you can do with something like CMake, for example, not sure if you can replicate the same thing with make files, but what I did when I remade my first game in C++ and I used raylib was I used a CMake file to actually obtain raylib if you didn't already have it on your computer. And that way, it's like you don't actually need to go through and install it manually. The build scripts, basically, like the CMake files, will actually set up the environment for you, which is really useful because it's just one less step for you to have to manually do. The other advantage with using CMake would be the fact that it doesn't really lock you into the make build system. So if you wanted to generate project files for Visual Studio or for Xcode or make files, you could do that from CMake. And generally CMake files are just easier to write than make as well. So I would recommend something like CMake or Premake as well, rather than going directly into make. But I think maybe the raylib make file just like it knows about the source directory and it will potentially, that's all raylib path, but maybe it knows about the source directory. Yeah, source directory equals source. So you define all your source files required for your project. I got it. And then they're obviously the Tetris specific source files are all here. And that way you don't really need to write your own build script or make file because raylib provides you with one and you can plug in your files basically. And since it's a raylib project, as long as you don't have any other external dependencies, it will probably just be like, okay, cool. I know what files of yours to compile. I'm done. So that's what I think is going on. Kind of reverse engineering this a little bit because I've never done it this way before. And I am kind of new to raylib. I just used it once, as I mentioned, for that Genesis remake project. But yeah, like I know that raylib, I think, also provides CMake files. So I would prefer those for the reasons that I mentioned. Anyway, let's go ahead and look at the actual code that we have here inside Visual Studio Code. So the way that I opened this project, by the way, was since it has a main.code workspace file, you can just go File, Open Workspace from File, and then just navigate to that file. And that brings us to this. And so if I try and just go Run, Start Debugging, then it will execute all the build script. It'll run make basically and compile everything and then launch it. And here we go. We are playing Tetris. Pretty sure you have to have some Visual Studio Code like extensions set up for C++ if that's what you want. Tetris. This brings me back. You know, I'm not that old, like to where Tetris was like a thing in my day, but I do remember playing it a lot at EA, funnily enough. We actually had an arcade machine. Oh, and it was Tetris where you played against each other. So it was like an arcade table and you kind of sit down and then you face each other and you verse each other. Or maybe that was a standing machine. I don't remember. But anyway, it was really cool because basically whenever you clear lines, you send lines towards like, you know, your opponent. So that was just really cool. Anyway, I love Tetris. I could play this for a while. I'm not that good at it, but I still enjoy it. All right, anyway. Yeah, look, pretty solid game. It works. It's Tetris. I don't know if it gets faster and if you like, you know, as you clear more lines or whatever, you get more levels. Yeah, it passes the test. Oh, can you slide in blocks? Let's try this. Yeah, you can. Okay, good. Because if you couldn't, that would be not. Yeah, there's like some Tetris test you can do, isn't there? Where like you need to test to make sure that the Tetris, like your Tetris game that you've made adheres to all of like the official kind of rules. Because if it does, oh, you can't stash things. That's fine though, I think. That's not OG Tetris, is it? So I don't know if this passes the Tetris test, but I don't think that's necessarily what we're critiquing here. Maybe code review should just turn into like Tetris review, and you guys send me all of your Tetris games, and then I verify them for like authenticity to the original Tetris and what it's supposed to be. Anyway, that's it. I'm clearing this and then I'm out. Okay, cool. Awesome. So taking a look at the main file, which is where it all begins, we just have new Tetris. So I like the fact that this main file is tiny. I don't know how I feel about new Tetris because again, like I think a lot of people do this. Let me see if I can find, this is Visual Studio Code, which I'm not that comfortable with navigating around. So forgive me if I'm a bit slow. So Tetris is a struct and we have a constructor here called Tetris. And that's, I guess, what runs here. And in this Tetris file, it just looks like there's the constructor, which has the main application loop, and then there's this function which isn't part of the class. So it's just this, and there's not even any storage here. Okay, so this is one of those situations where you don't need a struct, you don't need a class, you just need a function. So just make it a function, right? I think that C++, when you're learning C++ and when you're coming from other languages potentially into C++ as well, but also I think this is not just for those people, it's also the way that it's taught commonly in universities or schools is it's an object-oriented language. And so you get into this concept of like object-oriented programming is the paradigm that I need to follow in C++. That's obviously not true because C++ is very flexible, but I think that it's important in the beginning to develop some kind of code style. And even if it is something that is object-oriented like this, I don't think that's necessarily bad for beginners because I feel like it's hard for me to actually talk about this because I started programming with Java, which is obviously a very object-oriented language. And especially back then, I don't know if they're adding more features now where it's like, oh, you can be a bit more flexible, but back then it was very strictly object-oriented. And so that's the way I learned. The way that programming made sense to me in the beginning was everything is an object, everything is a class, and that's how you manipulate data, basically. And that's how you structure your code and your flow, and everything has to be around this notion that everything is an object, everything is a class. I think in the long run, that's not good because that's a far abstraction, if that makes sense, from like it's far away from what the computer's actually doing and how computers work. But it's something that seems to make sense to people a little bit more, I think, than just programming in a more data-oriented sense, even though that's, you know, if you want to produce good code and fast code and code that is more compatible with the way that your CPU works, you obviously have to be more aware of how the computer works and how sometimes it's helpful to reduce abstractions and make things more data oriented, essentially. And even back then though, with Java, I remember that part of me wanted to break away from that. Part of me was like, okay, but I don't need to instantiate this class with all of its data members for this. I just want to have a function. So I started making lots of things static because I was like, okay, these variables, they should just be static. This function, this whole class should just be static. Like it doesn't make sense because I just need to execute something. Maybe I have a data set that I provide through a parameter. I want this to just be a function. I don't need this whole class hierarchy or just like classes or an object system. That doesn't make sense. So for this specific example, there's a couple levels that we can go here. I would preferably just cut out the middleman basically and just remove this whole struct situation. But at the very least, what you should remember is there's just no need to call new. This is one of those situations where there's actually zero need to do this. And this is just harmful because you're doing more work than is required because there's 0 members here. So the size of this allocation will be 1 byte. When you call new Tetris, you're going to allocate 1 byte of memory on the heap. No reason why this shouldn't just be something that you create like this on the stack. It's still going to be a 1 byte allocation, but at least it's in like memory that's very hot and like in the cache. So it's readily available, but also it's not going to have to search for like, you know, 1 byte. Like we're not going to get too deep into how memory allocation works, but it's going to have to find like a spot in the heap that's at least 1 byte big, which is everything. But anyway, this is the more simple way to do that. And it comes with the added benefit of not leaking memory. So this, I don't know if I can call this a memory leak. It is technically in the sense that when you allocate this Tetris object, it gives you back a pointer, which you're not even storing. So therefore you have no way of deleting it. But because this is in the main function and it's the last thing, the first and last thing in the main function, you would be deleting it essentially straight after here, which would be the last thing in the main function. But then the main function ends and the operating system is going to reclaim the memory of the terminated application. So technically it's not really a leak of memory because you would never be reusing that memory, I guess, if that makes sense. And also the other advantage with deleting it manually would obviously be the calling of the destructor, but there is no destructor. So even though this looks sus, it's not actually that bad, but I would still say this is better, again, not for the reasons of the memory leak, but just because you're not doing a heap allocation for no reason. But as I mentioned, there's an even better way, at least in my opinion, and I'll show you that. But for the beginners out there, I want to share a really good resource that will help you learn programming a lot, and that is Brilliant.org, the sponsor of this this video. Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. And as I mentioned, I think they're a really good place to begin learning programming because their courses don't specifically narrow down into a language. They teach you how to think like a programmer, which, as we've sort of been discussing here, is really, really important when you're just starting. All of their courses are super engaging and interactive. They force you to actually do things rather than just watch. So for example, here in their programming courses, you'll have to drag around these things to define the flow of the program. Once you have learned a little bit more about how computers work and how they think, you can move on to an actual programming language like Python with the same fun way of teaching. And if you're learning programming, you're going to want to learn math as well. And Brilliant's courses go all the way down to the everyday math course, which is fantastic for beginners, and then through to things like algebra and calculus, which I definitely think benefits greatly from this visual interactive way of teaching, because playing with these widgets to see how the numbers actually work visually just helps so much. And the best thing is Brilliant has a 30-day free trial that you can use to just explore their platform and see all of the courses they have to offer. Just go to brilliant.org/thecherno, link will be in the description below. And if you do go on to like it, then that link will get you 20% off a premium annual subscription. Huge thank you to brilliant.org as always for sponsoring this video. So I mentioned taking out the middleman because we have this, like, if you just look at this, it's such a huge system that we have, so much infrastructure just to essentially call this code here. Like, why can't this just be void Tetris like this? We get rid of the struct, and again, we just have void Tetris like this, and well, that's it. Instead of doing all of this, you just call this. There's no allocation. It's just a function call, because you're not creating like an actual instance of a struct or a class. It's just a pure function. Let's actually just compile this and see if that builds, if it really is that simple. And there we go. And so even though this seems like such a simple change, not really that significant, because objectively it's not significant, like, right? Your game's not going to run 10 times faster now suddenly. But I think this is really crucial for beginner programmers, at least in C++, to understand that my objective here is just to call this code here. So I don't need to go through the labyrinth of like classes or structs or all of this architecture just to run these instructions basically, because I can just do something like this and that's it. Now, fundamentally, would I do it like this? Maybe, maybe not. The thing is, there's going to be data usually associated with an application and you want to store that data somewhere. And that's where I think the structs and everything come into play really well, because if we go back to like C and like just the introduction in the early days of like struct or structure, like what does that actually mean? That never had functions in it, right? You could have function pointers in it, but it would never really have functions in it. The whole purpose of this was always to just store data. I want to store like some variables, and instead of storing them, you know, just like this globally or like, you know, statically or whatever somewhere, I want to group them together into like a struct, and then I could have like, you know, an instance kind of that struct that is really just a collection of all of the data inside it, but it's one memory allocation that has all of that data contiguously that I can then share, you know, and refer to throughout my application, throughout my code. That was the whole reason why structs were created and why we like to use them. But then with object-oriented programming, structs kind of became classes, even though you can still use them as structs, and then you can just have them as functions. And then in a language that only supports object-oriented programming, if you want to have a function, it has to be within a class. Even if it's just static, it still has to be within a class. And that kind of almost pollutes the original reason why we even have these things. So in that case, if you did have data associated with your application, then I think it would be more than reasonable to just have your data defined here and then have functions that, you know, work on that data. I think that's a really nice way to just group things together and organize your code. But if you are in a situation that doesn't require that, like here, then obviously we could just have this function be completely outside of this struct and just not have that struct in the first place because it's just not needed. Moving on. So we initialize the window, set the target FPS, font. So this is another example. So it looks like this is probably the only place that actually draws this font. But if we did want to share this font in some way, we'd have to store it somewhere, and inside a struct or a class could be a valid place to store it. All right, game equals game. So with constructors like this, you just don't need this because it's just going to be called if you just write this code over here. Again, stuff like this makes me think that this person is in fact coming from something like Java or C#, because this looks wrong if you're coming from Java or C#. And the reason why is because it looks like a null pointer exception or a null reference exception. It looks like this is a crash waiting to happen as soon as you try and use this, because in Java, things are implicitly kind of pointers like this, or at least classes, objects are kind of like pointers like this. And so obviously this would be null because you haven't actually newed it into anything. In C# it's kind kind of the same thing. Structs in C# are like stack allocated instead of heap allocated. So there are some differences between, say, the new keyword in C++ and C#, but it's still that situation where, okay, if you haven't assigned it to anything, and if you haven't newed anything into there, then it is in fact null. And obviously you can't call a function on a null. In C++, things are different for two reasons. First of all, this again is an actual valid instance of the class because it has allocated the memory. It's called a constructor. As long as you have a default constructor with no parameters, it's done all that. That's just how the language works. And then even if you do this or whatever, and it's on the heap, and you try and call a function like this also won't just crash. So in a language like Java, this would immediately, you'd have a dot here instead, but this immediately would be like, that's it. You can't call a function on null. In C++, you can call a function on null, but then if this tries to use any member variables that are obviously in the memory of the allocation of the class that never happened because it's null and you never called new, then it would probably crash because of like some access violation, or because you're trying to read like an offset from 0 that, isn't valid memory, doesn't actually exist. But if you just had a function handle input, and let's just say it did nothing with the member variables of this, then technically it's just a function and you didn't use any member variables or the actual instance itself. It might as well just be a function like this, and that would actually, work and not crash the program. So it's interesting how the languages are quite different. And I think, again, becoming like a C++ programmer and getting more experience with language, you need to understand things like this. So we have the instance of game, which I'm guessing contains most of the stuff that runs the actual gameplay, which we'll explore in a minute. This is just pretty standard Raylib stuff. Event triggered is the function that we had up here, which is interesting. So we have an interval that goes in, and I guess it looks like as long as current time minus the last update time, which is just a global variable stored up here, which this is another example of maybe this should have been a function inside your struct, and then this variable could have been a variable inside the struct. That's probably how I would do it. But anyway, we have a function here that looks like it checks to see if the interval has passed since the last time, but the last update time is actually set within this function if the interval's passed, interestingly. Okay, so yeah, so this is a bit weird. The reason why is because basically it updates the last update time when you call this event as long as it triggers. So you can't really use this more than once. Like it is used once, but if you wanted an event to happen every 0.2 seconds, so every 200 milliseconds, I guess we move a block down. That's just the kind of tick rate, the update rate of the game. You can't really reuse that function like this, for example, because if you had a code like this, you'd actually never end up calling this, because as soon as 100 milliseconds passes, you would set the last update time to the current time, and then so it's back to 0 basically. The difference would be back to 0, and then you'd accumulate 100 milliseconds again and return true. I do think it's a little bit of a weird function because it kind of implies that you can just call it with an interval, and then every 0.2 milliseconds it will call this, which it will do as long as you only use it once. So that's interesting. And then down here we have the rendering. We use that font to draw the text, and then this is fun. We've got some like C stuff here. You wouldn't typically see this stuff in C++ these days because like this is like a C-based thing. It's used, I imagine, because this needs to take in a const char pointer in the end. So what this does is it actually allocates just some chars on the stack, and then you're putting that game score into there. And as long as it's not more than like 10 digits or whatever, you won't have an issue. But we're using sprintf, which is the string version. So I'm guessing that'll put like a null termination character on the end. In C++, typically the way we would do this these days is you'd probably have a string, and it would be like, let's just say your score, and then that would be std format, and then you'd probably just do, percentage d. You'd just do this, or 0 or not, or whatever. If you wanted it to decimal places, if it was a float, you could probably do something like that, and then you just do game.score. So that's probably the way you do this, and then obviously you could just do score.cstring. Now this is obviously overkill. This will probably run faster in this case because we need it to be a C-string anyway. We need it to be a const char pointer, but this I would say would be like the modern C++ version. You could also do, because it is just the one thing that's a score, like you don't have text like this where you actually need both of the things concatenated. You could also do something like this, where you just have std2 string, and then it would convert like an integer into a string for you to use. This is also more compatible with older versions of C++ because std format I think is C++ 20, so it's quite modern comparatively at least. But those are just some C++ ways to do that in case you want to know. But yeah, in this case, like I don't really have anything against this, to be honest, just because I think this will perform the fastest out of everything I've mentioned. It's just my might look like a little bit messy. But then also like it doesn't hurt to potentially have like a game dot, get score string or whatever function that just does that. And then you could actually have this char maybe sitting within, like this char buffer sitting within the actual game class. And then all you would do is, that way you could basically have something like this, right? And that would just look a lot cleaner. So I think that you could definitely clean this up, but the fundamental way that you're kind of getting that score string, I think is fine. All right. And then we have all this stuff. So let's actually get into some of the gameplay and the way that that works, because that's interesting. So we have this game class over here, which just runs the game. Again, stuff like this, right? We have grid. And it's grid. That's actually already done its job, right? That's already done its job of creating the instance of this class. So this is just a waste of life. That line of code doesn't need to exist whatsoever. In fact, it's extra annoying because if you have this line here, what happens is it's going to actually run the constructor once over here. Just when you create this game class, it's going to run the constructor over here as part of the initialization. And then when you run this line of code, it's going to run the constructor again and replace that object. So you're actually running the constructor twice here, which is, I think, annoying and unnecessary. Let's have a look at how the blocks work. So we've got this class called block, but then we've also got a file here called blocks. So if we take a look at blocks, this is how they're all subclasses of block, and block has this map of cells, which I'm guessing defines the layout, I guess, of that particular block. So if we have a look at this L block, for example, you can see we've got this like cells. So cells 0, 1, 2, 3. Okay. So just because I know a little bit about Tetris, been around the block a few times, I'm guessing these are the 4 possible rotations. So if we try and find is cells used inside here, get cell positions. So how do you okay, rotate block, here we go. So current block dot rotate, we'll do rotation state plus plus. If rotation state is, okay, yeah, we just loop back to 0, same with here. So all we do is we adjust the rotation state, meaning what orientation is the block in, because obviously you can rotate it like to 4 different orientations. And then that rotation state, I'm guessing, is going to be an index into cells so that we get like the layout of that particular block, like cell by cell, based on the current rotation state. Now, one quick note about this. As we increase the rotation just by adding 1 to it, we check to see if we hit like the out of bounds, I guess, index of the rotation, because we know that there's just 0, 1, 2, and 3. So if we do plus plus and we end up with 4, then that's bad and we should reset back to 0. But there's a much simpler way to write this, and that is by just using the modulus operator, right? So we can just there's a couple ways we could do this, but the simplest way maybe is just to do something like this, right? So we know we have 4 rotation states. So you can just do mod and then the number of states you basically have, because what this will do is it will divide the number and then tell you the remainder. Effectively, what that does is when you add 1 to this, if you get to something like 5, because 5 divided by 4 will give you like, I guess, 1 with a remainder of 1. 1 is the thing it will take, and you'll just get 1 as a result. So basically, as you keep increasing the rotation state, you're just gonna, as soon as you get to 4 divided by 4 is 1 with a remainder of 0. So you go back to 0 and then you start building 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. That's just how it's gonna loop. The way that I'd probably write this would just be rotation state plus 1 and then mod 4, just so it's all on one line. So you could do something like that. And again, instead of mod 4, you probably want to do that. And that obviously makes it a little cleaner. Now for undo rotation, same situation. It's just that we're going backwards. Now going backwards isn't gonna quite work if you try and do the exact same code like this. So if you just do rotation state -1, it will still work, but you're going to get negative numbers. And if you don't want negative numbers, there is actually a trick that you can use. It's kind of a trick. It's a cool trick. And that is you also do a plus, but you do plus 1 minus the total amount that you actually want. So in other words, for this situation, instead of it being rotation state equals rotation state plus 1 mod 4, which we want, since mod 4 is what we're doing, we would add 3 instead. And that would effectively subtract 1 without going negative or being weird. So it's a pretty cool little trick. And obviously the way that you would write that is like this if you wanted it to be dependent on cells.size. Cells.size, by the way, is a size t, which is a 64-bit unsigned integer, which is why I'm casting this to an int, just because this is an int. And the original author, Adam, actually had it here to begin with when he did his if check, probably because it gave him a compiler warning. So I'm keeping that here. But you could obviously just bring that out like max, just like max or something. I don't know, max. And then that might look a little bit cleaner. And then obviously you don't need this. So that's a cool little trick, I guess, for going backwards if you need to with the rotation state. Over here as well, I couldn't help but notice the lack of variables being initialized. They are initialized here, but I just feel like in modern C++ or whatever, unless you do need to like call a function or something, you should initialize these here, right? So cell size should be 30, rotation state, 0, like whatever you end up setting it to. I would just initialize all of these here, or you can also use the initializer list as well. The reason why, it doesn't really matter with variables variables so much. The problem with if these were actual objects like there are in game, so like block, then you would either do it here or in the initializer list to avoid calling the constructor twice like I showed you earlier. However, because these are variables, it doesn't matter too much, but it's just nice to, I think, look at the header file and see these, like what are essentially fixed values, just be over here. And it kind of just makes the actual constructor cleaner because it just does the thing that, you know, might be an actual function call or whatever over there. So anyway, point is, this is just kind of for organization purposes, not really going to functionally change anything. So if we go back to the blocks, so these are all the different rotations, and then we have essentially just a kind of a coordinate system over here, right? So we have a grid from like 0 to 2. I'm not sure if 0 is up here or up here on the y-axis, but we'll just assume it's in the bottom here. So 0, 2, for example, would be 0 on x and 2 on y. So we'd have like a block here, I guess. And then 1, 0 is 1 on x and 0 on y, which is over here. Then we have 1, 1, which is here. And then we have 1, 2, which is here. And that's kind of our L block, as you can see. But then with rotation 1, I'll do this in blue. We have 0, 1, which would be over here. We have 1, 1, which would be here. We have 2, 1, and then we have 2, 2, which is up here, right? So you can see that we have that same block, but then we just have different orientations of it. And also, yes, in Tetris, generally your blocks are defined just as individual cells like this because they need to be able to rotate, they need to be able to fit with other cells, they need to be able to get deleted partially when you clear lines. So generally, it's just a collection of like 4 cells, I guess. And that's what all of these blocks do. They're just subclasses of that original block class with the cells updated to be different based on the block type, obviously. Okay, so that's how the blocks work. The blocks have a bunch of different colors, which are defined over here. And then the header file has them marked as extern, just so that we can, I guess, globally access them. So this is another, I would say, older way of doing it in C++. If you want basically a bunch of global variables that are constant like this, instead of having them be extern over here in the header file and then in the CPP file having them actually defined, you can just use the inline keyword instead. So if you use inline like this and then you just set dark gray to like, you know, whatever it was set to, you can have them all nicely defined in the header file. You don't need the CPP file at all. I mean, you could keep it for this function if you really want, but I'd probably just stick this in the header file. And actually I'd probably have this vector be either like an array, just like a static fixed array, or have it defined also as like an inline static or whatever. So you're not creating it every time you call the function. But the inline keyword over here is basically what lets you have this be a global variable that is just defined once. Because what happens is, since this is inside a header file that you will presumably include in multiple CPP files, if you don't have any keyword here, then it's like you're creating this variable. Since you're copying and pasting the header file into the CPP file, it's like you're just creating this variable over and over again. You have multiple copies of it in each CPP file, which wouldn't work because it's global. So it'll tell you that it's already defined. And if you have it static, it will work, like it'll compile, but then you just have a different version of it in every CPP file. So there's still different variables. If you get the memory address of dark gray inside Tetris.cpp, if you include colors there versus in colors.cpp or in blocks.cpp, the memory addresses will be different because you'll have a different version in each. Now it will still work because the versions that you have the same data, but then why have different versions? That doesn't make sense. So instead we just have inline, and that lets us just have the single copy. Even though it's in a header file, you still have that kind of single copy to link to, I guess, throughout your entire project, even if you include it everywhere. So generally that's how that works. Now, the other thing that I don't like is the fact that this is just a global variable called dark gray, right? If we just search for this, maybe, I mean, we do have this colors array, so maybe that's the only way that it's actually used. But like even here, like draw rectangle rounded, and then it's just dark gray. Like that feels weird to me. I would prefer having this a little bit more organized, maybe in a namespace called colors, like at least have something like that. And I'd probably capitalize it that way. When you refer to it, say over here, you'd have colors dark gray like that. And that just makes a little bit more sense to me. To be honest, all of your code should probably be in a namespace that's like called Tetris or like, I don't know what, like with the name of the game or whatever you want to call it, just to differentiate this, because this is the other annoying thing. Like ArrayLib will provide their own things like this. These are actually defines, which are colors. And then you've got this here. And it's like, okay, this is from ArrayLib. This is from your code. It becomes hard to tell. ArrayLib, I don't like the fact that ArrayLib also has no namespaces. It's a C library, so it's allowed to have no namespaces considering namespaces don't exist. But with C++ code, I think you should definitely be putting your code into namespaces. And I mean, you know, black, white, okay, well, that's all capitals, so that must be ArrayLib. This is all lowercase, so this must be your code. You know what I mean? Like, it's a little bit ambiguous. I don't really like it that way. So that's why I would probably prefer to put this into like a namespace. You could also put it into like a struct if you wanted to. That way you could technically avoid using inline. So you could have a struct called colors, which you'll never instantiate or anything. And then you'll just have, you know, static const color, dark gray and whatever. And then it's the same situation. You just do colors colors dark gray or whatever, you use a thing in the struct, it's static anyway, it doesn't matter. And yeah, you don't need inline. And of course, there'll be only one copy of it because you don't even really create the colors struct instance anywhere. So that's another valid way, I would say, to do it. But the way you've done it with extern and, you know, having the implementation, it's just like, I just have everything defined here. You don't need anything here. That's the other thing that I should probably mention. This is a function for some reason. It really doesn't need to be. You could just have a inline const variable, just called like cell colors or something. And then you would just set it to this, like that. I've just put it on 2 lines so it fits, but that's it. You don't need a function. You don't need a function call. You don't need to create more instances of this or like create like a new array every time you call the function or anything. It's here. That's it. So I'd probably put this into a namespace just to keep it a little bit more organized, but that's how I would rewrite your color situation. And then yeah, the CPP file, you just delete that. That doesn't need to exist whatsoever, because assuming you follow through with all of this, everything just exists here and that's it. The last thing I want to mention is just in general, this use of vector that's happening everywhere. So this is next to where we were looking at the rotations. I just noticed this out of the corner of my eye. Don't think I missed it. A very common thing that beginners do is what I would say is misusing vectors, specifically obviously the vectors that are inside the standard template library, the dynamic arrays. std vector in C++ is what I would consider a fragile class, in the sense that like it needs to be used a very specific way if you care about performance at all, right? Like you can't just copy it wherever you like. You can't just push back items however you like. If you want to use it properly, if you care about performance, then you have to know how to do that. And there are 2 things that could easily be improved here. The first is what's happening over here is we are grabbing cells at a rotation state, right? There's this vector within this map, and we're just copying it into this new vector. So what we've done here is we've created a brand new vector, we've heap allocated the memory, and we've copied every element from the cells over into that freshly allocated heap block of memory every single time we ask for cell positions. And asking for cell positions is obviously something that sounds like you would be doing pretty often, right? So every time you need to check if the block is outside, you need to get the cell positions. Anytime you need to check if a block fits, you need to get the cell positions. And so what's happening every single time is you're doing all of these copies. What you've actually done here and what you want to do here, because this doesn't need to exist, this line at all, is you're just trying to alias this. So instead of you then, because tiles is used once over here, instead of you writing this, which is perfectly acceptable, you've decided to make it its own variable, presumably just because it tidies up the code a little bit, which is fine. You can do that. You're allowed to do that. But just stick this little character here. It's called an ampersand. This just makes it a reference. And in fact, if you want it to be a little bit more correct, since it's basically a read-only variable here, you're not going to be writing to tiles, you can make it a const reference as well. And what that does is it just lets you use that as normal, but it doesn't create a copy of it. It uses the exact one that's in here. So we're using like that one in place, but we've made something called an alias for it, like another way to address this exact variable and to use that exact variable that is here. And obviously that can make your code cleaner. So that's step 1. And in general, when you write functions like this, you should always consider, should this be returning a reference or a const reference of a vector? Now here it's a bit different because we're literally moving this stuff or whatever, like we're creating like a new vector here. So obviously we can't return it by const reference unless we can cache it or do something else with the vector that we're creating. But let's just assume for this case, we have to actually create a vector. Here, the second issue that I said we had is the fact that we just create this brand new vector over here, and then we push back a whole bunch of this new position, right? Which is this position that I guess has been transformed in some way into moved tiles. Now, obviously the amount of times that we push back is the same as tiles.size because we're iterating through tiles, and for every item inside tiles, we're pushing back this new position into moved tiles. So what that means is that we actually know how many we need. So in that case, you should absolutely pre-allocate that memory. And you can do that in a couple of ways, either by just doing this, right? So move tiles, we're creating a new vector with tiles.size. The reason why, by the way, is because let's just say there are 4 of these. In the very beginning, vector is going to have a size of 1. So when you push back the first thing, no problems. Then it's going to basically double in memory the next time you try and push something back, because 1 is not enough to hold 2 elements. So it's going to times 2, it's going to double that memory. I'm pretty sure it does times 2 in MSVC's implementation of this. I think in some other compilers, some other libraries, it might do plus 50% or whatever, but either way, in this case, that would be the same thing because it'd have to round up. You can't have 1.5 elements. So it rounds up to 2. So you do another allocation. So right now we've done 2 allocations, the initial one and then this second one over here to push back the second one. And then since there are 4, number 3, when that needs to get pushed back, is going to have to double again to 4 elements storage so that it can push back element number 3. Then our element number 4 will come with no allocations. So we've done a total of 3 allocations just here, and actually a 4th one, I guess, over here. So this one little function of yours has done 4 allocations. Now with my little adjustments here, with having tiles.size here, you've gone from 4 to 1 allocation, which is going to be much faster. So that's why you would do that. Now in this case, if you do actually put it into the constructor like that, that's the same thing as calling resize with tiles.size, by the way. And the problem with that's not really a problem, but it's already actually created empty elements there. So when you push back, it's not actually going to push back at index 0 for the first time because there's already 4 elements in there. It'll push back at index 4. So 0 to 3 will be just empty tiles. So you have 2 ways of solving that. Either you change this for loop to be a normal for loop instead of like a for each loop, in which case you do, you know, tiles.size or whatever you want over here. I guess you'd write this as size t as well. And then instead of push back, you just do move tiles I equals new position like that, in which case you could obviously make this a little bit cleaner by doing something like this. That could be a valid way of doing it. If you wanted to keep the for each loop, I guess you could also do in I equals 0 and then just do I plus like that. So you're kind of adding an index here. That's also valid. Or if you wanted to keep the pushback for whatever reason, maybe you just like the way it looks, then you could also just change this to be reserve instead of resize. And what reserve will do, and then you'll just get rid of this over here. What that will do is it will allocate the memory, so the capacity of the vector will be enough to store 4 elements without allocating more memory and doing like a reallocation, but it's not going to insert those like empty elements. So the size, if you ask the size of this vector, it will still be 0, but the capacity will be 4, which is what you want. And then finally, even if you do it this way, I would change the push back to an emplace back, because that saves you constructing this element here and then copying it into the vector when you do pushback. Instead, you can just take the parameters of the constructor and put them here. And it's basically like you're forwarding the parameters into the vector, which will call the position constructor and actually create that element in place already inside the vector. And so that's what it might look like. So this is the more solid way, I guess. This is the more professional way, we'll call it, of just dealing with vectors and doing what you want to do here. I probably wouldn't bother like trying to cache this or whatever. I think this is plenty fast enough. It was probably fast enough for a Tetris game before this, let's be honest. But this is a nice habit to get into, just to treat vectors with respect, treat vectors correctly, treat them right, because vectors can be a huge source of issues and like performance problems down the line if you're not careful at larger scales. But overall, nice project. Game functions really well. Code, I think, is pretty clean for the most part. Nothing here is making me be like, for the thumbnail, so we're good. If you guys want me to review your code, send it into chernoreview@gmail.com. There'll be that email address as well as some instructions in the description below. Check that out. What did you think of this code? Did I miss something? Did you like it? Did you not like it? What did he do wrong? What did he do right? Leave your thoughts in the comment section below, and I will see you next time. Goodbye.